Today we're going to be looking at direct variation, and a direct variation function, it can be written as y equals kx, where k refers to the constant of variation. With a direct variation function, one variable is directly affected by the other variable. So here's an example of a direct variation function. Gas costs $3.42 per gallon. Your total bill, so we're going to call that y, varies directly. Those are the words we look for in direct variation, with the number of gallons that you buy, and we will call the number of gallons x. So the constant of variation, which is the unit rate, would be $3.42. So it's $3.42 per gallon. The direct variation equation, so your total bill, y, is equal to 342x. So 342 times the number of gallons. That would be your direct variation equation. This is y equals kx. Note there is no y-intercept here. There's no plus a number or minus a number if you were to graph this. Now, let's say you are doing a problem where you don't know the constant of variation. Let's say maybe you have a problem where it says that you have, it costs you $30 and you buy 10 gallons. And so to figure out the cost per gallon, you would say 30 equals k times 10, divide by 10. So k is equal to 30 over 10, which is 3. So your unit rate there is 3. So for your direct variation equation, you would write y equals 3x. So k is going to be y over x. So whenever you're looking for a k, you can do y over x. All right, so to graph this, let's make an XY chart. So if we think about the domain, what would be the smallest amount of gas you could put in? Well, you could start at 0, not put any in, and the cost would be 0 then. You could not use a negative number here because we don't put in negative gallons of gas. Then we could put in 1, for example, and we would have 342 for our total. You could put in 2, it would be 684. You could put in 3, that would be 1026. And you could keep going. You could even put in 1.5 or 2.5, whatever. Let's just graph those real quick. So we start at 0, 0, and we go over 1 up 342, over 2 up 684. Right about there, and over 3 up 10.26. So just a little more, and you can see we have a line right here. So when we talk about the domain of this function, domain refers to your x values, or what your inputs can be. The minimum that you could put in would be 0. So you would say x is greater than or equal to 0. So we look at another problem. The price you pay for gasoline varies directly with the number of gallons that you purchase. You paid $23.98 for 11 gallons of gas. So if you think about this, what don't we know here? We know what the total was, and we know how many gallons we bought, but we don't know our unit rate or our constant of variation. The next time you paid $26.53, how many gallons of gas did you purchase? Well, what we first want to do is figure out what that unit rate is. So when you work with direct variation equation, what I like to do is when I see the words varies directly, I put a k above it. And whatever's on the left here, so the price, we're going to call that y, which is our total. So the total cost is y, and the number of gallons will be x. So the k varies directly. Whatever you have on the left will be your y, and whatever you have on the right will be your x. So we write y equals kx. Let's just start with the general form of direct variation. And here they tell us one situation so that we could figure out what our constant of variation is. You paid $23.98. That is the total, which is Y. So you put $23.98 here, and we don't know K. And X, we had 11 gallons. The gallons would be X, so we put that in right here. And now we're just going to divide to solve. So $23.98 divided by 11. K would be 218. That's the constant of variation. So for this problem, the direct variation equation is y equals 218x. So that's the first part of the problem. And now using that information, we'll be able to do the last part. It says the next time you paid $26.53. That's your total, so that's a y. How many gallons of gas did you purchase? That would be an x, and we don't know that. So now we will substitute in $26.53 into the equation like this, and divide by 218 on both sides. So x equals 1217 about. So we got about 12.17 gallons of gas, so we could write gallons. All right, let's do another problem. The price you pay for gasoline varies directly with the number of gallons that you purchase. Again, I see varies directly, so I'll put a K right there. The price will be Y, and I'm going to put total right here. So the total cost is Y. And the number of gallons we will call X. In the first situation, they say you paid $27.72 for 14 gallons. So we start out writing our direct variation equation, just the general one. And then we'll substitute in the Y value and the X value. And to find K, we divide both sides by 14. So we get $1.98. So the direct variation equation for this problem is y equals $1.98x. So then in the next part of the problem, it says, next time you only purchase 12 gallons. Well, gallons, the number we purchase is x, so we will put 12 in for x. And we end up with $23.76. That would be our total cost. So here's another type of problem. The salesperson commission varies directly with sales. Oh, varies directly. I will underline that, put a K above it. So it's the salesperson's commission, which will be the Y, varies directly with sales. That will be the X. So for $1,000 in sales, so that's an X, the commission is $85. That's a Y. So the general equation is y equals kx, and we will substitute in our x and our y here. 85 equals k times 1,000. So to solve, we divide. So k equals 0.085, which would be, if we move the decimal over, 8.5%. So the direct variation equation 0.085 times x, which is the number of sales. So then it says, what is the commission for $2,300 in sales? Sales is x, so that will go in for the x. And we get $195.50. Another problem, the number of calories varies directly with the mass of cheese. Varies directly, that's a K. The number of calories, we'll call that Y, and the mass of cheese, we'll call that X. So Y equals KX. So in the first example, they say if 50 grams of cheese, well, that's the mass, and so that's an X. contains 200 calories. The calories are the y. And now we're able to figure out what that unit rate is, or constant of variation. So K equals 4. So the direct variation equation that expresses this relationship is y equals 4x. In the next part of the problem, it says how many calories are in 70 grams of cheese. So this is going to be your mass, so that would be your going for your x value. So that would be 280 calories. So now, let's go back and look at the direct variation equation is y equals kx, which means if you solve for k, divide both sides by x, k equals y over x. So with direct variation, k is always equal to y over x. So for each of these functions, we have to determine whether y varies directly with x. So if they do, the constant of variation would be the same for each pair here. So what we do then is we look at the constant of variation for each pair. So y over x would be 2 over 1, which is 2. Y over x would be 6 over 3, which is 2. Y over x would be 8 over 4, which is 2. Remember, y over x is equal to k. So in this problem, k equals 2. So this is your constant of variation. 2 is. And to write the equation then, we just substitute that into y equals kx, so it would be y equals 2x. And that would be your direct variation equation. So in the next problem, it says determine whether y varies directly with x. So we have to look at y over x in each situation. So this would be 4 over 1, which is 4, 8 over 2, which is 4, and 11 over 3, and that's not equal to 4. So because the constant of variation isn't the same throughout, this is not direct variation. And now we're going to graph these, and if you recall, when we have linear equations in the form of y equals mx plus b, the m stands for your y-intercept, the m stands for your slope, the b stands for your y-intercept. So in this problem, the k is actually like an m. We have a slope of 3/4, and the y-intercept is 0 since there is not a number here. So to graph, we first plot our y-intercept, which is 0, and the slope is 3 over 4, which, remember, slope is rise over run, so we can go up 3 over 4, up 3 over 4, or we could go down 3, back 4, down 3, back 4. And then you just draw your line. So there's the graph. In the next one, y-intercept is 0. Your slope is -2, which is the same as -2 over 1. So the rise is a -2. So you're actually going to go down 2 and to the right 1. Remember, when you have a negative slope, your line should be falling as you look from left to right. And so this would be the graph of this function. So just a few problems here. It says in number 2, identify the constant of variation. So remember, general form is y equals kx. The constant of variation is the k, the number in front of the x. So k would equal 3/2 in the first problem. In the next problem, the problem is not in the slope-intercept form. So the first thing we need to do is solve for y. And then we'll divide by 4. So y equals 5/4 x. So your constant of variation is 5/4. And just remember, when direct variation, when you look at those equations, the y-intercept is always 0. So when you are solving an equation, if you have a y-intercept that is anything besides 0, it is not direct variation. The next problem says, write a function rule for the direct variation in the table. Well, first we need to figure out what k is. Remember, k is y over x. So y over x here is negative 1/2. Here it's negative 2/4, which is negative 1/2. And here it's negative 3/6, which is negative 1/2. And so your k is equal to negative 1/2. So the direct variation equation is negative y equals negative 1/2 x. And the assignment is right here. And on one of the problems in the book, number 21, I just want to talk about that. They give you some different direct variation relationships. They say, well, y is equal to 7 and x is equal to 2 in this direct variation relationship. And then it says, what is x when y is 3? So the first thing we need to do is find the constant of variation. So write y equals kx. And we'll substitute in the y and the x value that they give us and divide by 2 to find k. So k, your constant of variation, is 7/2. So in this problem then, the direct variation equation is y equals 7/2 x. The next part says, what is x when y is 3? So then we have to substitute 3 in for the y. And to solve that, we could multiply by the reciprocal of 7/2. So multiply this side by 2/7, and then you would multiply this side by 2/7. So the 2's cancel, the 7's cancel. So x would equal 6/7. That's your final answer. And that is it for this lesson. Please see me if you have questions.